vector valued functions are functions like this. Something like this, where you plug in a value for t and you get back a vector. Another way to think about it is like you plug in one single real value, real number, and it gives you a tuple of a tuple of 3 real values. And we've covered this kind of functions as like trajectories in space where points move, right? We also explained that if you differentiate this, you get the velocity, and if this is a trajectory, then you differentiate this, you get the velocity, and if you differentiate that again, you get the acceleration, and so on and so on. So we've already covered the derivative side of this vector valued function. What I want to do is I want to do the integral, okay? So what's the integral? Well, assume that instead of this being a trajectory, let's say this is a velocity. And here's a question. Find the displacement from time t equals to 0 to t equals to pi over 2. How do you do this? Well, remember that integral of velocity gives you displacement, and integral of the norm of the velocity. What's another name for norm of the velocity?
Speed.
Speed, right? Velocity is a vector, okay? So norm of the velocity, which is the same as speed, gives you distance traveled. And this is really equals to arc length of trajectory. I kind of explained that things that look like, oh, this is not really a, if you have this as the velocity, then if you integrate, that's going to give you t squared, right? If you have t squared, that has acceleration. So this is like a helix where it's going round and round because of this in some manner, but then the z, so it's doing this, or it's probably clockwise. So it's something that's going this way, but it accelerates as you go. So it's like it's a spring where initially it's densely packed, but as you move along, it becomes like widened. So it's like that's the kind of shape that you have. But anyways, so make sure you know the distinction. So when you have questions about arc length, you have to take the norm of the velocity and then integrate. But if you want the displacement, then you have to integrate without taking the norm. You just have to integrate it as it is. You should also know that displacement is a vector. What's a displacement? If you have trajectory that does this, then the displacement from here to there is simply terminal minus initial. Yeah, it's this vector. Okay. So the terminal point minus the initial point. This vector is what's known as the displacement. It doesn't care about what happened in between. It just looks at the beginning and the end, and you get a single vector out of it. Okay. That's what displacement is. I should try to use a red marker for that one. All right, so let's actually do the computation. So you should integrate from 0 to pi over 2 all of this sine t, cosine t, and 2t. And you integrate just like how you do the regular integration, except that you just have to do it component-wise. And integral of sine t is negative cosine t. Integral of cosine t is sine t. Integral of 2t is t squared. By the way, this is a definite integral, so you don't put plus c. But if you are to do an indefinite integral, in that case you have to put c1, c2, c3 for each one of these, okay? The constants don't have to be the same. That's why you have to say plus c1, plus c2, plus c3, all right? Yeah. But this is a definite integral, so you just have to do this and then say t is 0 and t is pi over 2, and now you just have to plug things in and subtract, okay? So what is cosine pi over 2? 0. Sine pi over 2 is? 1. Pi over 2 squared, so it's pi squared over 4. Minus, when you plug in 0, what's cosine 0? Cosine 0 is 1, so because there's a minus, you end up with a minus 1. Sine 0 is? 0. And 0 squared is 0. Okay? So you end up with the vector where it's 1 comma 1 comma pi squared over. Right? That's the that's the displacement. Yeah, that's right.